All right, let's jump right in. What if I told you that empty space isn't actually empty? It's a wild thought. Today we're going to dig into one of the most fundamental ideas in all of physics, the electric field. This is an invisible reality that shapes, well, everything. And it all kicks off with a question that sounds super simple, but is anything but.
I mean, think about it. How does a force actually work across empty space? How can something over here affect something over there with nothing in between? This very question completely baffled early scientists. It made them rethink everything they thought they knew about space itself. To really get why this was such a big deal, let's start with what they could see. So first up, the known force. We're talking about an interaction we can actually observe. Before we get into the weird stuff, we've got to ground ourselves in what we can see and measure. Okay, let's do a quick thought experiment. Picture a single electric charge. We'll call it a big Q, and it's just sitting there, all alone, in a total vacuum. Nothing else around. Simple enough.
Now let's bring in another smaller charge. Let's call it little q. The moment we place it near our big Q, boom, Q pushes or pulls on Q. Opposites attract, likes repel. That's just basic physics, Coulomb's law. We can measure this force. It's totally predictable. But again, how? How does that force jump across the gap? That's the real head-scratcher.
And that brings us right to the heart of it. Section 2, the empty space puzzle. Seriously, this is a question that completely changed physics.
Okay, let's go back to our little setup. We've got our main charge, Q, just hanging out. But now, let's just pluck that little charge Q right out of there. It's gone, and this one simple move opens up a huge can of worms.
So what's left behind? Right at that spot where Q used to be, what's there now? I mean, the logical answer seems to be nothing, right? Just empty space.
But is it? Is there really nothing there? Is the space around our big charge Q totally unchanged?
Because here's the paradox. If that spot is truly totally empty, then how does it instantly know to push or pull on Q the second we put it back? How does that information travel from Q to Q through nothing instantly? This whole idea was called action at a distance, and for scientists, it just felt wrong, like magic.
Okay, section 3, the invisible influence. To get around this magic, scientists came up with a brilliant, game-changing idea. They said, what if the space around a charge isn't empty? What if it's filled with something?
And that something is what we now call the electric field. The whole concept is that a charge doesn't just exist in space. It actually changes the space around it. It creates this condition, this invisible influence that's just waiting there.
And this is the really big shift in thinking. Our source charge, Q, is creating this field everywhere around it, all the time. It doesn't matter if another charge is there to feel it or not. The field is always there. It becomes a property of the space itself.
So, this new idea of a field completely changes how we think about the force. It's no longer a one-step mystery. It becomes a really logical two-step process.
Here's how it works. Step 1. Our big charge Q creates its electric field everywhere around it. Simple. Step 2. When we bring in our little charge Q, it's not Q that affects it directly from a distance. Nope. It's the field, right at the exact spot where Q is, that pushes or pulls on it.
See the difference? The old idea was that Q acts on Q across this empty void. But with the field concept, Q creates a field, and then the field acts on Q. It gets rid of that whole spooky action at a distance thing. The interaction is now local. The charge Q only cares about the field in its immediate vicinity. It's such a clean, elegant solution.
It all boils down to this. The field there acts on it and produces a force. That's the whole thing. The force isn't some weird message being beamed across the universe. It's a local interaction. And that one idea, that simple statement, was a huge, huge leap forward for physics.
Okay, last part. Why does any of this matter? Well, this whole field concept isn't just some clever workaround. It's a completely new way of looking at the universe.
You see, the electric field isn't just an idea in a textbook. It's a real thing. It has physical properties. It can store energy. It can carry momentum. It is just as real as the particles themselves. All of a sudden, space isn't this empty, boring stage anymore. It's an active participant in the cosmic drama.
So, let's just nail down the key takeaways here. 1. Charges change the space around them. They don't just sit there. 2.
We call that change the electric field. And 3, the big one, forces are transmitted by this field, not magically across empty space. The mystery of action at a distance is solved.
And once this idea of a field was out there, it just unlocked everything. It led to our understanding of magnetism and even gravity, thanks to Einstein.